We need to learn 2 points in this video. The first point is the definition of vectors, and the second point is how to determine direction. Let's start with the first point. Regarding quantities, we have some quantities that we can define with just a number, such as a person's weight, a person's height, or temperature. In these cases, the number alone is sufficient. On the other hand, we have quantities where the number alone is not sufficient. We must provide a direction in order to identify the quantity. For example, in the aviation world, if we are determining an aircraft's position, we need to know its speed and its exact direction. The same thing applies when we deal with wind. It must have a speed, and we need to know its exact direction. In physics lessons, we also saw vector quantities, which are electric current and magnetic field. The value alone is not sufficient. We need to know both the value and the direction. We saw the importance of determining the direction of electric current and magnetic field in order to find the direction of the resulting force. So now we've agreed that some values require only a value to define them, and some values require both a value and a direction. The second point, how do we determine direction? We must have a reference or an agreed upon recognized method for determining direction. In each field, they agree on a specific method. We're going to learn two methods, quadrant bearing and true bearing. Quadrant bearing, from its name, we divide into 4 directions. We draw the vertical line here for north and south, and the horizontal line for east and west. Now we have 4 squares bounded between 2 directions. So if the vector is up here in the upper section, we measure from the north, and if it's in the lower section, we measure from the south. For example, if the vector is here at 45 degrees from north, we say N, which is for north, then 45 degrees, then E, which means it's heading toward the east. But if it's here, it will be 45 degrees, but in the direction of the west. In the second quadrant, we say N45 W. If the vector is in the lower half, it will be closer to the south. We'll do the same thing, but we'll start from the south. Finally, we have the true bearing, which quite simply we measure from the north in a clockwise direction, and we write it as 3 digits followed by the degree symbol. We don't need to write north or south because it's understood. If we see 3 digits followed by a degree symbol, we know it's a true bearing. So what was N45 E becomes 45 degrees. And the vector that was N45 W, we'll measure this angle from the north to here, which is 315 degrees.